The 15 HP Bovar Company half-breed engine is a vintage two-cycle gas engine widely used in early American oil fields. Built for reliability and endurance, it powered drilling rigs and pumping systems in western Pennsylvania, eastern Ohio, and northern West Virginia. The term half-breed refers to its hybrid design, combining elements of steam and gas engines. Producing 15 horsepower, it was strong enough for heavy industrial tasks, yet simple in construction, requiring minimal maintenance. Weighing around 5,000 to 500 pounds, this durable engine became a workhorse of the oil industry, symbolizing early innovation in petroleum-powered technology. The 1913 Dion-Bouton V8 engine is one of the earliest V8 engines ever built for automobiles. Produced by the pioneering French company Dion-Bouton, it featured a 90-degree V configuration and water cooling. With a displacement of about 7.8 liters, the engine delivered around 40 horsepower, powering luxury and high-performance vehicles of its era. Its design combined two V4 cylinder blocks, showcasing advanced engineering for the early 20th century. The Dion-Bouton V8 represented a major step forward in automotive technology and influenced later V8 developments by manufacturers such as Cadillac and other early car makers. The Duvant 9 VOS is a massive diesel engine produced in 1962 by the French company Duvant. This powerful machine, weighing about 30 tons and measuring over 18 feet in length, represents the engineering excellence of the 1960s. As a Type 9 VOS model, it was among only 3 ever constructed, making it an exceptionally rare piece of industrial history. Built for heavy-duty applications, the engine demonstrates advanced design and durability typical of French mechanical innovation during that era. Today it stands as a remarkable example of large-scale diesel engine engineering. The Atlas Polar diesel engine, built around 1927, was successfully started again in Cabrianes, Spain, after being idle since 1978. This remarkable restoration was achieved with the dedicated efforts of Dirk, Gerard, Jean-Bernard, Sebastien, and André, who spent a day and a half carefully preparing the engine for operation. After decades of silence, the historic machine came back to life, demonstrating the robustness of early diesel engineering. The team cleaned and inspected the system, check the fuel and lubrication circuits, and manually turn the flywheel before ignition. The engine, which had run on tar oil during its last years of service, still requires some adjustments for optimal performance. Its successful restart marks an impressive revival of industrial heritage and a tribute to the craftsmanship and perseverance of its restorers. The V16 locomotive engine is a 16-cylinder diesel engine arranged in a V configuration with two banks of 8 cylinders. It is widely used in diesel-electric locomotives, providing exceptional power and torque for both freight and passenger trains. Instead of directly driving the wheels, the engine operates a generator that produces electricity to power large traction motors connected to the wheels. The throttle controls engine speed and electrical output, regulating train motion. Additionally, during dynamic braking, the traction motors act as generators, converting the train's kinetic energy into heat through resistors, improving efficiency and braking performance. The Mazda T600 is a three-wheeled light truck powered by a 600cc, air-cooled, overhead valve V-twin gasoline engine producing 20 horsepower. This compact yet robust engine delivers reliable performance and smooth operation, making the T600 suitable for light transport and commercial use. The power plant is mid-mounted, optimizing weight distribution and stability while driving. With this setup, the T600 can reach a top speed of about 50 miles per hour. The engine was developed as an export version of the smaller 356cc unit used in the Mazda K360, which was designed primarily for the domestic Japanese market. By increasing the displacement to 600cc, Mazda enhanced both power and torque, allowing the T600 to handle heavier loads and longer routes more efficiently. The Sanderson Cyclone drilling rig engine, seen operating in the field at Coolspring, is a remarkable example of early oilfield power technology. Designed specifically to drive drilling rigs, this engine combines strength, durability, and steady performance in rugged field conditions. Built in the early 1900s, the Cyclone features a large, single-cylinder design typical of oilfield engines of that era, running on natural gas or crude oil drawn directly from the well. Its robust flywheels ensure smooth power delivery, while its open-frame construction allows for easy maintenance and repair on-site. The engine's rhythmic, deep exhaust sound and slow operating speed demonstrate its power and reliability, traits that made it invaluable for drilling and pumping operations in remote oil fields. Restored and displayed at the Coolspring Power Museum, this engine now serves as a living artifact of industrial history, showing visitors how mechanical ingenuity powered the development of the oil industry. Watching the Sanderson Cyclone run today is like stepping back in time, witnessing firsthand the engineering craftsmanship and mechanical endurance that fueled the early days of energy exploration in America's oil fields.
pleasure.
The Bessemer oil-filled engine, recently retrieved from an oil lease in Warren, Pennsylvania, is a remarkable example of early American industrial engineering, built for the rugged conditions of oil field work. This engine was originally used to power drilling rigs and pumping units. Designed for reliability and endurance, Bessemer engines earned a reputation for their robust construction and smooth operation. The recovered unit is now part of a new exhibition at the Pioneer Steam and Gas Engine Society in Seegertown, PA, where it joins two 20-horsepower Franklin valveless engines and an oil well supply system. These engines together demonstrate the vital role mechanical power played in early oil production. Restoring and displaying the Bessemer engine not only preserves a valuable piece of energy history, but also showcases the transition from steam to internal combustion power in America's oil fields. Through its rhythmic chug and steady motion, the Bessemer continues to tell the story of an era when innovation and determination fueled the growth of the oil industry across Pennsylvania and beyond. The Shvetsov M11 is a 5-cylinder air-cooled radial aircraft engine developed and produced in the Soviet Union between 1923 and 1952. It was the first mass-produced Soviet aircraft engine and became one of the most widely used power plants for training and light aircraft. Designed in response to a 1923 competition for a reliable trainer aircraft engine, the M11 featured a single-row, 5-cylinder radial configuration with aluminum cylinder heads, ensuring efficient cooling and reduced weight. Unlike many radial engines of its time, the M11 employed individual camshafts for each cylinder instead of a central cam ring, offering improved valve timing control. Early versions of the engine delivered around 100 horsepower but had a limited service life of approximately 50 hours. Through continuous development, later models achieved significant improvements in both reliability and power output. The M11D variant increased power to 125 horsepower, while the M11FR, introduced in 1946, reached 160 horsepower at 900 revolutions per minute during takeoff and 140 horsepower during cruise. This final version also featured provisions for variable pitch propeller, accessory drives for pumps and generators, and a floatless carburetor for better fuel delivery. Renowned for its simplicity, durability, and ease of maintenance, the Shvetsov M11 powered numerous iconic Soviet aircraft, such as the Polikarpov Po-2 and Yak-18, leaving a lasting mark on aviation history. Experimental Lycoming IO-360 aircraft engine undergoing a test run. This four-cylinder, horizontally opposed air-cooled engine is fuel-injected, delivering reliable power for many light aircraft and experimental builds. With a total displacement of 360 cubic inches, the IO-360 is known for its durability, smooth performance, and efficient combustion. The test setup allows precise monitoring of engine parameters, ignition timing, and propeller performance. Often used in home-built and certified aircraft alike, the Lycoming IO-360 remains one of the most popular piston engines in general aviation, valued for its proven design and adaptability. The Continental IO-470E is a six-cylinder, air-cooled, horizontally opposed aircraft engine widely used in general aviation. With a displacement of 470 cubic inches, it produces up to 260 horsepower at 2,625 RPM. Featuring a fuel injection system instead of a carburetor, it delivers smoother operation, better fuel efficiency, and improved performance at high altitudes. The engine's robust aluminum construction ensures reliability and long service life. Commonly installed in aircraft such as the Beechcraft Bonanza and Cessna 182, the IO-470E is known for its dependable power, smooth running characteristics, and suitability for both private and commercial aviation.